Okay, let's talk about one of the most interesting erosional features on planet Earth: marine canyons. Let's check out this canyon here off the coast of North America. Let's first get an idea of its width. 1 point, almost 1.2 miles, which is the size of as wide as the Columbia River is today. Let's get a comparison going. Right, so it's actually much wider than most of the Columbia River. I guess this is probably one of the widest points. Let's check this. 3 miles. So we actually have a connection between the Columbia River, which cuts through the Cascade Mountain Range, and then as it goes to the ocean, it connects right here. Now look at how massive this canyon is here. You know, from the top across, that's 7 miles. Okay, and it continues, but it's not just one canyon. There's canyons all over the place, and they keep going, and they connect, and they form this canyon here. And as we follow it offshore, makes a sharp turn here, comes through this little ridge here, is able to break through. It keeps going. It branches off and then reconnects. Now this section right here is one of my favorites because you actually get the cliff and terrace step sequences. One, 2, 3. That's pretty amazing. And the width, 4.4. So it's still wider than the Columbia River. And the depth here is 3,600 meters. So that's basically 10,000 feet deep. So how do you get a 4-mile wide canyon 10,000 feet deep? That's a big question, but they actually have an answer. And the consensus answer to this canyon, I actually agree with. And I think they're completely right on their understanding of this canyon. So how do these canyons form? All right, let's look at the Puget Sound. The Puget Sound is quite an amazing piece of erosion because you got a sharp turn here, comes around here. This is all underwater scablands, and then it goes and it connects and adds to this canyon that I just showed you. So how do these canyons form? How does these canyons form here? These are much wider. 15 miles wide, about 16, 15 miles wide, but 1, 2, 3 right next to each other. So it's not just 15 miles wide out of a huge watershed. This is a very narrow watershed, right? They're just, when you have 3 big canyons right next to each other, that's an indication of sheet water flow. And the watershed isn't a funneling shape, it's just straight into these mountains. So it's a very interesting feature, something you wouldn't really expect if you hadn't been studying erosion as a catastrophic event, as I have. Everything in erosion is catastrophic. That's just how I see it because I've been studying it for so long. Look at these winding turns. Absolutely beautiful. And the depth is 3,000 meters, so 9,000 feet. So how do you get these winding turns 3,000 feet deep? Or excuse me, 3,000 meters deep, which is 9,000 feet, over 9,000 feet. That's a tough question to answer, but this feature here actually gives us a hint. right? See this deposit? Now this is kind of blurred out. I don't know if they have the data for this or not, but this is basically a fjord that comes around and comes out here. And when they get more data on this and they show it clearly, I guarantee you that that's a nice deep canyon that turns and goes right into here, right into this deposit. That's telling us exactly how these features are formed. Okay? I'm going to show you a video I made called Marine Canyons Deep Water Catastrophe. Now this is how they form. There's an erosional feature called debris flows. These are the front edge of debris flows, they can move massive boulders. And these happen in flash floods and steep mountain terrain. So this is footage from Switzerland. Switzerland is known for having these incredible debris flows. And as I showed in the beginning, this first clip here, see how this debris flow charges right into this river? This debris flow has so much inertia and power and force behind it that it's going to erode and be a powerful force on this river bottom. Even though it's underwater, it doesn't matter. It's got all this energy coming downhill, and this is full of big rocks, muddy water, and it's much more dense than this fresh water here. So it's going to erode underwater. That's exactly how these features are formed. You're having debris flows just like what we saw in Switzerland. And here's the deposit to prove it. But these debris flows, they kept going and they kept going and they turned. And they don't care about the water depth because they're made out of rocks. Rocks sink and they got a lot of inertia and a lot of power. And they keep going and they keep going. Okay, so that's my insight to how these features are formed. Now, the consensus actually completely agrees with me. You ask scientists how these features form, the answer is underwater debris flows. But they just don't quite grasp the scale of these debris flows. So I'm going to show you, I'm going to map them out. So this is the one that starts from the Columbia River. I'm going to start here, and I'm just going to map out this debris flow canyon feature. We're already at 100 miles, and we've barely gotten off the continental shelf. This one kind of disappears, but you can see right here how it connects here. So I'm just going to probably goes something like this. Connects here. You know what, actually, let's just do the Puget Sound one. It's better. Okay, so the Puget Sound, I mean, I could start it all the way here, but I'm just going to start it. I'm going to start it right at this corner. And we're just going to get a rough idea for how big this feature is. Already at 200 miles. 300 miles, no sweat. 400, 500. 600. Now that's that amazing feature that shows the terraces. That's just the best spot ever. That actually shows the decrease of the debris flow, and the trail end of the debris flow is actually a mud flow. I'll show you that later. And then we go here. Here it branches around. And this is the last spot we see this one. So it's about 900. We can trace it for about 900 miles. But where it ends, the width of it, where it ends, it's over a mile wide. So stand somewhere and look a mile away and imagine a mile wide debris flow. This is 4,000 meters deep. A mile wide debris flow, two of them coming around here, making a streamlined intermediary. 4,000 meters deep. And that's the last we see of it, right? We can only assume it keeps going. So that's one heck of a debris flow if you ask me. But we're just getting started. Let's start with this guy here. Let's just start here. Kind of on the continental shelf. We drop off the continental shelf. We come around here. If I measured all these corners exactly, there's a lot of turns in here. It'd be way longer, but I'm just going to show you guys a rough idea of how big these, or how long these trails go. And so there's kind of blurry spots, and then we can find it again. So we're just getting a rough idea. We can see it over here, and there's a bunch of them. They're all next to each other. This is 4,300 meters deep. Okay. And we're at 1,000, just about 1,000 miles offshore. Is this one here? Look at that. There's a little piece of one. So that'd be, over 1,200 miles. If we were able to trace this whole thing, we see this guy here. Let's get a width on this guy. Oh my gosh, 2 miles wide? I mean, get out of town. So the reason why these debris flows are so insane, or here, let's talk about this. How is it able to be pushed forward? So all of this area here, this is all relatively flat. It's going hundreds of miles over relatively flat terrain. How is that possible? Okay, I'll explain it to you. This debris flow is coming downhill. It's being pushed. There's a continuous chain of pressure pushing it forward. Okay, these rocks are being pushed by all of the mass that's uphill going down steep terrain. These canyons in Switzerland are very steep. Okay, so what's able to push and turn these massive boulders is all the water and mud above it. Let me show you another clip. Okay, so here's the debris flow, and behind it is the mud flow. The mud flow is much more dense than water. It's got a lot of mass, and it's pushing it. So we can't see the front of this debris flow. It's way downhill. But all of this still has inertia, and it's pushing it. It's like a continuous chain of pressure. It's like traffic. If somebody rear ends you and you rear end the person in front of you, you're going to keep rear ending people in front of you if there's someone way back there that's just slamming you guys, right? If there's a semi truck that just runs into the back of traffic, it's going to have a continuous chain of pressure pushing the debris flow forward. So that is the key for this debris flow to travel hundreds of miles offshore, is that there is a continuous chain of debris flow pressure that's going off the continental shelf, down these mountains, and pushing it over this flat terrain. And the canyon width's 2 miles wide. So we're talking about a catastrophe of catastrophes here. And you can find debris flows all over the place. Okay, there's a really good one here. This is a debris flow. This is 1,000-mile long debris flow. Comes along. You can see these canyons here. 4 miles wide. So it's 1,000 miles long, 4 miles wide. The depth, 43,000 meters. Okay, there was a catastrophe that came from here down.